Welcome to our segment on nebula. We'll be seeing some amazing scenes from across our galaxy. In recent segments, we've seen two types of nebula. Both have been connected with stars dying. Planetary nebulas such as NGC 2371 are all about normal stars at the end of their hydrogen-burning life. And supernova remnants, such as SNR 0509, are the remains of giant star explosions at the end of their fusion factory life. But the most beautiful nebula come from vast molecular hydrogen clouds where new stars are being born. To understand these areas a bit better, we need to know a little more about nebula. There are three basic kinds: reflection nebula, emission nebula, and dark nebula. Reflection nebula are clouds of interstellar dust grains that are reflecting light from a nearby star. This Witch's Head Nebula is an example. It is reflecting light from the nearby star Rigel. In this photograph, the blue color of the Witch's Head Nebula is caused by the dust grains scattering blue light. The same physical process causes Earth's daytime sky to appear blue. Emission nebula are shining their own light. In order to do that, the gas and dust need to be excited to the point of luminescing. This is accomplished in two primary ways. One, by exploding stars at the end of their lives, like the two we just saw, and two, by new stars exciting the clouds they are born in. The Rosetta Nebula is a good example of this. This nebula is a vast cloud of dust and gas extending over an area almost 100 light-years wide. It would cover our entire solar neighborhood. As parts of a great molecular cloud condense, new stars are created. These hot new stars shine brightly in the ultraviolet. This is exactly the right wavelength for radiation to ionize hydrogen molecules and atoms by stripping away their electrons. This sets off a series of quantum effects that create photons in very large numbers, creating the light that we see with our telescopes. You can see the young, recently formed stars situated within this nebula. They formed from the nebula's material, and they are the stars that make the nebula shine. Areas like the one creating the Rosetta stars are called H2 regions. There are only a few thousand of these in the Milky Way because they only last a few million years. Radiation pressure from the hot young stars drives most of the gas away. The Pleiades are an example of a cluster which has boiled away most of the H2 region from which it formed. Only a trace of blue reflection luminosity remains. Our third kind of nebula, dark nebula, are not shining at all. They are clouds of dust and gas that are positioned in front of bright nebula obstructing its view. The Horsehead Nebula is an excellent example of this. Rising from a sea of dust and gas like a giant horsehead, the nebula is one of the most photographed objects in the sky. It is a cold, dark cloud of gas and dust silhouetted against the bright nebula. The most interesting nebulae in the Milky Way are made up of all three types: emission, reflection, and dark. So let's take a look at some of these scattered across our galaxy. The cloud surrounding the star system Rho Ophiuchi, or Rho Oph for short, is one of our closest star-forming regions. Rho Oph itself is a binary star system visible in the light-colored region on the right side of the image. The star system is distinguished by its colorful surroundings, which include a red emission nebula and numerous light and dark brown dust lanes around 5 light-years wide. Near the image bottom lies the Blue Horsehead Nebula. The blue glow that surrounds the blue horsehead's eye is a reflection nebula. You can't see the stars behind the clouds in visible light, but X-ray and infrared brings them into view. The bright pink objects are young stellar objects. These baby stars are just now forming. Many of them are still enveloped in their own tiny compact cloud called their baby blanket. There are more than 300 young stellar objects within the large central cloud. Their median age is only 300,000 years. And that's very young compared to some of the universe's oldest stars, which are 12 to 13 billion years old. This spectacular wide-field image shows the area around the star R Corona Australis. A huge dust cloud, about 8 light-years long, dominates the center of the image. At its tip in the upper right is a group of lovely reflection nebula. It is the smaller yellowish nebula that surrounds the young variable star. This is a very detailed image of the dramatic effects of very young stars on the dust and gas from which they were born. The baby stars are invisible in this picture, being hidden behind dust clouds at the upper left of the picture. But the material they are ejecting is crashing into the surroundings at speeds that can reach 500,000 miles per hour. These shock waves cause the gas to shine and create the strangely colored glowing arcs and blobs known as Herbig-Haro or HH objects. Four light-years across, this close-up of an area in the northwest region of the large Iris Nebula seems to be clogged with cosmic dust. With bright light from the nearby star illuminating it from above, the dust resembles thick mounds of billowing cotton. It's actually made up of tiny particles of solid matter, with sizes from 10 to 100 times smaller than a grain of dust we'd find here in our homes. This is the giant Orion Molecular Cloud Complex. The image covers an area with objects that span about 75 light-years. It holds a number of beautiful and well-known nebula, including, of course, the Orion Nebula itself in the upper right. The brightest 3 stars on the left are the 3 stars that make up Orion's belt. The top star is Minetaka, about 900 light-years away. The middle star is Alnilam. It is a blue-white supergiant around 1,300 light-years away. The lowest star is Alnitak. It is only 700 light-years away. So you can see that these 3 stars are in line with the Orion cloud, but not a part of it. Below Alnitak is the Flame Nebula, an emission nebula in filaments of dark brown dust. Just to the right of Alnitak is the famous Horsehead Nebula. Moving over and up to the Orion Nebula, we also see the Running Man Nebula just to the left of Orion. This Hubble mosaic of the Orion Nebula covers 24 light-years across and reveals numerous features that reside within this nearby, intense star-forming region. More than 3,000 stars of various sizes appear in the image. The Trapezian open star cluster contains hundreds of brand new stars. The first of these Trapezian stars were discovered by Galileo. They got their name because the first stars looked like a trapezoid. As we scan the outer edges of the nebula, you can see the illuminated walls of the Orion Cavern, along with beautiful, elongated jets created by nearby stars being born. This is one of my personal favorites. It's the bipolar star-forming region called Sharpless 2-106. It appears in a relatively isolated region of the Milky Way galaxy and measures several light-years in length. A massive young star, called Infrared Source 4, is responsible for the furious activity we see in the nebula. Twin lobes of superhot gas, glowing blue in this image, stretch outward from the central star. A ring of dust and gas orbiting the star acts like a belt, cinching the expanding nebula into an hourglass shape. Hubble's sharp resolution reveals ripples and ridges in the gas as it interacts with the cooler interstellar medium. The dusty red veins that surround the blue emission are also illuminated by the central star. This pillar of gas and dust is called the Cone Nebula. We're looking at the upper 2.5 light years of the pillar. The entire nebula is 7 light years long. Radiation from hot young stars located above the top of the image have slowly eroded the nebula over millions of years. Swirling dust clouds and bright newborn stars dominate the view of this image of the Lagoon Nebula. Within these clouds of dust and gas, a new generation of